Hey there, ladies and gentlemen. Here's topic 3.1, diversity of organisms in salt and fresh waters. This is a pretty important section, and so it's going to be a longer video, so hopefully I don't ramble on too much. I'll try to stick to the point. You're going to need some of this for the big project that I'm going to be presenting either next week or the week after. You're going to have to do a research project on a animal and aquatic organism. Some of the things that you're going to need are in this presentation. So let's get through it. Okay, so first off, we're going to talk about diversity. Okay, diversity is something that's pretty important. Um, Diversity is a healthy thing. Okay, you hear about it a lot. You hear about Canada, how diverse Canada is. It's one of the things that makes us so great. And when we're talking about that type of diversity, we're talking about different people, different ethnicities, religions, orientations, all those types of things. When we're talking about diversity on an ecological scale, we're talking about similarly differences. Okay, all the differences. So would you say this pond is healthy? This would be a classroom discussion. And the answer is yes. This is a very healthy pond. Probably wouldn't want to go swimming around in it with all of the bugs and things in it. But the fact that there is a lot of different organisms in this pond tell me it is a very healthy a healthy pond. So we would have a classroom discussion. Do you think a developer wanted to destroy this for housing and whatnot? Would you support it? Would you not? And this is pretty interesting. We get a pretty good discussion going on. Some people say yes, we need a place to live. Others would say no, we want to conserve the wildlife. And Airdrie, in my opinion, is doing a pretty good job at conserving as well as developing for homes. Anyone that lives in the canals down in Kings Heights, anyone that lives near a big water body, you know, and you may notice that we're trying to, or they're trying to have healthy ecosystems coexist with homes and houses. Okay. So lots of living organisms in here, and like all ecosystems, the healthier the ecosystem, the more diversity or the more diverse the organisms would be. Back when I worked in the field, I went to a lot of lakes and swamps and whatnot, where all you would find were these little midges, these tiny little wormy things. Those were very unhealthy ecosystems. I spoke on one of my other videos about Lake Normandeau and how the diversity in that lake. The number of organisms went down to just two, three species of fish, and they're probably all gone now as well. So the more diverse the ecosystem, the healthier it is. So diversity in fresh and saltwater systems. Previous years, you guys learned ecosystem is any place on Earth where living and non-living things interact with each other. So abiotic, ambiotic things interact together. Different variety of living things in a particular ecosystem describes that area's diversity. So the more abundant the different numbers of organisms, the more diverse that ecosystem is. Sorry, going through this fast. Don't want to have a 40-minute video here. Many different kinds of organisms live in freshwater, lakes, rivers, but the ocean obviously supports a greater diversity of living things. Now, why do we think that is? Why do you think, even though lakes and rivers and streams, they have a lot of organisms in them, why do you think the ocean has even more, greater diversity? Okay, and that's because number of reasons. Okay, it's larger. Obviously, the ocean takes up the majority of the planet, so that would make more sense. But there's also different types of environments. Okay, different types of environments in the ocean, different layers of the ocean, and actually two-thirds of all the organisms on the planet spend part or all of their lives in the ocean. Okay, and so here's a beautiful picture right out of our textbook of a lake ecosystem and lake diversity. Okay, you can see there's a lot of diversity. The diversity is typically greatest here in the shallower areas. We got a lot of plant life, we got a lot of small bugs, fish, those types of things. And as we get deeper, the organisms do get a little bit larger, but the diversity also gets a little bit smaller. Okay, there's going to be a Bill Nye video that corresponds with this type of stuff. So we're not going to spend too much time talking about this. We're going to let Mr. Nye teach that. And then we go next to our ocean cross-section image from our textbook. Okay, and again, very similar. You see the diversity, but the big difference here is we're seeing there's still a greater diversity in the deeper areas than greater diversity in the deeper areas than we would find in like a lake. Okay, but again, some of the most diverse areas are the areas right along the shoreline. I highly recommend you guys look in your textbook, hint, 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 for some quiz questions on these sections, on the estuaries, on the intertidal zones, the continental shelf, the oceanic zone. Know these different zones, know what happens inside them, what some of the different organisms are, because there's going to be a few quiz questions. I'm going to leave it up to you to find some of that, but there's also a Bill Nye video that goes along with the ocean. So that's why we're going through it very quickly. So in order to live in all these different areas in the water, there have to be adaptations, okay? We know, I played the adaptation song for you guys, the camel song that drove you guys nuts, at least my class, I'm not sure if Ms. Rainey's did, but an adaptation is a physical characteristic or behavior of a species that increases its chances of survival in a particular environment. Typically, when we're thinking out here, we think of the hares that are running around, okay? So the rabbits. The hares in the wintertime, they turn nice and white so they can blend in with the snow. Spring, summertime, like now, that white fur changes to a brown fur so they can blend in with the surroundings so they can hide from predators. We're going to be talking about aquatic adaptations specifically for aquatic organisms. So that whole example of the rabbit does not really fit in here. Okay, so all living things have adaptations that are specific to them for the environments that we live in. That's all living things, including us. I'm sure you can think of adaptations we have. They also need to continue to adapt. Organisms are always adapting, especially if their environment changes. Now, some of those could be physical adaptations, some of those could be learned or behavioral adaptations, but we are constantly adapting. So, can you think of any adaptation species or aquatic species have? Very quickly, some that we would talk about in class are obviously gills. Okay, we talked about natural antifreezes back in one of the other units that fish have to help prevent them from freezing. We have some organisms that give off their own light, the aerodynamic shape of fish, gills. We start thinking of birds. Certain birds can dive under the water, others fly away. Some have the locking talons that catch onto fish. All of these are adaptations that help species that are aquatic or live in aquatic environments. Okay, and you could go on and on and on, and you guys are going to be finding some of them for in your research project. So I'm not going to go ruin it all for you. So here's a beautiful picture. You guys all know who these two are. Hopefully, I'm not going to copyright on this one, but we have Dory and Marlin. It's Merlin Marlin, the daddy. That's not Nemo, or maybe it is Nemo. I don't know. But yeah, we've got these two guys. Okay, we all know who these two are. They're the two fish from Finding Nemo. What would happen to them if we were to take them and replace them in our lakes? Okay, so this is where we would have a big classroom discussion. Okay, very first thing I have on here, they are bright colored fish. We have these nice bright colored fish swimming around in our lakes. Are they going to be there for very long? Probably not. Those big pike or trout or something would gobble these up in a heartbeat because they are so bright. They stand out. If it's not another fish, maybe a bird flying over will see them and swoop down. So obviously, they'd quickly die because of that reason. So they'd because they're so bright, they'd be eaten by a predator. Okay, they're also warm-blooded, or not warm-blooded fish. They are saltwater fish. They live in tropical water. Okay, they live in warm temperatures. Our water would be too cold for them. Okay, they would freeze. They would die fairly quickly. They're not adapted to live in our our cold environment. They're adapted to live in their warm environment. Okay. Also, they live in salt water. Okay. Our lakes are not fresh water. These organisms that live in salt water, they've been adapted to be able to withstand the salt that is in their environment, and they don't lose the water. And through osmosis, they don't lose the water that's in them into the salt water. If we were to put them into the fresh water, they would end up by having too much fresh water. The fresh waters, their body systems would not be able to survive the freshwater conditions. So these are some of the environmental factors that help these organisms or that organisms have that help them lead in aquatic environments. Now, we're going to talk about 5 factors. 5 great questions. Test questions, maybe. Okay, 5 factors that lead to adaptations specifically for aquatic organisms. The first one's temperature. So I already talked about this, and I'm sorry, I'm talking about a lot of things here. But fish from Finding Nemo have adapted to live in warm temperature, warm tropical environments. Our fish, the northern pike and trout species, they obviously live in cold water. Okay. There are fish in the Arctic that have adapted by developing, like I mentioned before, an antifreeze that prevents their body and their blood from freezing in really, really frigid water temperatures. Okay, so I'm thinking fish like Arctic char, probably some Arctic trout. A lot of the fish that we have up north, some whitefish, mountain whitefish, and some of the lake whitefish that are way up north, their bodies would have been adapted to this. Some minnow species as well, Arctic grayling. Okay. Um, all the fish that are at Balzac, the Balzac Mall, a lot of those are trout species of fish. So because they're trout species of fish, there's most likely a chiller on that tank to keep the temperature nice and cool. If the temperature was to go up, the fish wouldn't be able to survive. They would end up by dying. Also, we talked about how oxygen levels are highest, gas oxygen levels are highest in cooler water. So the temperature going up might decrease the amount of oxygen that's in the water. And it's not necessarily the coldness that kills the fish, but it's the lack of oxygen that would end up by killing the fish. So those fish have been adapted to live in colder temperatures or in warmer temperatures where the temperature is obviously different, or maybe the gas or the amount of oxygen is different. Another adaptation is light, and we can go and talk about Finding Nemo here. As water gets deeper in lakes and oceans, obviously the amount of light that penetrates decreases. Okay, lakes are lakes because they are so deep that there's areas where the light does not penetrate, that the light does not go to the bottom. Oceans are obviously the same way as well. So there are areas of lakes where there is no light present, and there's areas in the ocean where there's no light present. But both of these zones have aquatic organisms that live in them. So organisms that live in these areas have to survive without light. Walleye, fish that we have out here, very sought after, good game fish. Walleye have adapted to living in low light areas by having those big giant pupils. They have huge eyes with big pupils on them that allow, like you guys remember from the light and optics unit, allows more light into their eyes so that they can see. And here's a nice picture of a nice walleye, and you can see that huge pupil in the fish. That's a huge pupil. The fish is outside. There's a lot of light getting into that fish's eye right now. But when it's in the water, there's less light, so it's going to help the fish be able to see in dark areas. There's also fish like the dragonfish, which lives deep, 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 deep in the ocean, and they actually have spots on their body called photophores that produce their own light. Other fish that have similar things like that, there's a beautiful dragonfish. Other fish that have adaptations like that are the anglerfish, which use I think Finding Nemo, use that little ball that Dory goes and tries to catch before, and then it goes and tries to eat them. Okay, and there's a flashlight fish, I believe, in our textbook. So there's a lot of different fish and organisms that generate their own light. Can you think of others? Yeah. Another factor is pressure. So going back to the dragonfish in the previous slide, that fish lives deep, deep, deep in the ocean. Fish that live deep, deep, deep in the ocean have to obviously adapt to having low light, but they also have to adapt to having all the water that's above them pushing on their bodies. Okay, we talked about the bends in one of the earlier units where if you're scuba diving, you come up really quickly, the amount of pressure that's pushing on our body changes really, really quickly, and it could cause blood vessels and things like that to pop. Well, these fish that live deep, deep in the water, they've adapted to have all of that pressure of the water pushing on them. And that's why if you go fishing, deep sea fishing or something like that, and you catch a fish that's really, really, really deep in the water and you reel up too quickly, a lot of times you'll be reeling, 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 having a pretty good fight like fish normally would, fishing like you normally would when you're fishing, and then all of a sudden your rod would go limp, and you'd be like, "Oh darn, I snapped the line, or the fish bit the hook, or something like that." But as you're reeling it in, you see the fish; it actually does pop up, and there's something trailing it at the end of the fish, and there's no fight or anything. And what happened is you're reeling too quickly that the fish has not had enough time to adapt to the changes in pressure that its insides essentially started getting bigger, 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 and popped. Okay, and part of its insides are on the outside. So yeah, like that's something that these fish have adapted to living. So in addition to living in the dark, they've adapted to, or living in the dark, they've adapted to living in areas where there's so much weight pushing on them. Okay, and yeah, that leads to what I was just talking about. Another thing is salinity. So we've talked about salinity at the beginning of this unit, and that measures the amount of salt in the water. Well, we know there's fish and there's organisms that live in fresh water, and we know there's some that live in salt water. Typically, a freshwater fish, if we were to take a northern pike and go throw it into the ocean, wouldn't survive. It's not adapted to live into the highly salty conditions, and vice versa. If we were to take Nemo and throw it into freshwater, they wouldn't survive. However, there are some organisms that can survive in both. Salmon are a perfect example. Salmon, we always hear they swim upstream. They swim upstream into fresh water. This is where they go and they spawn. They have their little babies. Parents die, and the babies spend a part of their life in the fresh water. They then eventually migrate out into the salt water and spend a nice part of their life in the salt water, and then they come back to the rivers and streams and whatnot to lay their fresh eggs, and the circle of life continues. In the Bill Nye video, there's going to be they're going to talk about if I'm showing you the right Bill Nye video, they're going to be talking about some about spawning of salmon and whatnot. So it's pretty interesting stuff. Next is water movement. So there is water that, we have fast flowing rivers and streams. We have slow, stagnant lakes. And in those different water bodies, uh, we have different species of fish. Arctic grayling are a perfect example of a fish that lives very well in fast flowing water. You typically don't find them in stagnant lakes. Whereas northern pike, you'll find them in both. You'll find pike in rivers, you'll find them in lakes. Another adaptation for water movement, though, goes all the way back to the beginning of this unit, which we talked about a couple weeks ago, was tides. Okay, so we talked about high tide and low tide. And we know as the tide goes up, a certain part of that area is covered by water over a certain amount of time. And then as the tide goes down, a certain part is covered not with water. That typically, though, down below, you have a lot of barnacles and things like that that spend part of their lives or part of their day in underwater, part of their day outside of water. These organisms have adapted to living in these types of conditions where water levels fluctuate and change. Okay, so some organisms like to live in areas where their water moves strongly. They need to be able to withstand that water movement. So Arctic grayling, again, I was talking about that when we used to have to go out and catch Arctic grayling. We'd go and we'd be casting into some of the fast flowing water, and we'd catch some nice little grayling there. But barnacles, they've adapted by attaching themselves to rocks and things like that. And you might remember from one of those Pirates of the Caribbean movies where that boat with the squid guy went in and out of water. You'd go down underneath water, and then when it came time to go plunge the and rob and steal and do all the nice things that pirates do, they'd come out of the water, and all of the pirates had these on them, barnacles and whatnot. Obviously, this is not real. It's make believe, Disney, etc., etc. However, I loved the fact that they had these characters with barnacles and things like that on them because they spent part of their lives or part of their time underwater, part of their time above water. So these organisms were able to adapt to living in both conditions. That is it. Okay, I went through that fairly quickly. I'll throw on some application questions. I will also be putting 2 Bill Nye videos up and 2 Bill Nye quizzes to go with them. One on ocean life, one on lakes and ponds. I think it's lakes and ponds. Great videos. I'm going to throw the quizzes on there just because it's easy marks. But definitely watch the videos, write the quizzes, and we'll go from there. If you have any questions, like always, send me an email. Have a good one, guys.